Now, if we have a frequency distribution table like this, and we want to calculate the descriptive measures. In this example, he asked me only to find the mean, but we will find all the descriptive measures. Let's start with the first measure, which is the mean. If we have a frequency distribution table and we want to find the mean, we have a formula. The formula of mean is what? Mean equal sum of f multiplied by x divided by the sum of the frequency. The sum of the frequency means a number of elements which is n. So to find the mean, we need to create a table. We will use the same table. For this table, we will construct one more column called x times f. We will multiply, because we want to find f times x, we will multiply each value of x times its frequency. Now let's start. 3 times 4 equals 12. 5 times 10 equals 50. 6 times 18 equals 108. 7 times 20 equals 140. 8 times 24 equals 192. Then 9 times 20 equals 180. 10 times 14 equals 140. 11 times 10 equals 110. 12 times 5 equals 60. Then we want to find the sum. So let's add all of these values. When we add all of them, we will get 992. Now, to find the mean, we will divide 992 divided by sum of the frequency, or n, which is 124. So the mean in this case equals 8. Next step, let's find the mode. To find the mode in this example, as you know, a mode is the most repeated value. So look at the frequencies. What is the greatest frequency here? It's 24. So the value opposite 24 is the most repeated value. So the mode in this case equals 8. Next step, let's find the range. A range is the difference between the greatest value and the smallest value. What is the greatest value here? Greatest value is 12. Minus the smallest value is 4. So 12 minus 4 equals 8. So range in this case equals 8. Now we want to find the standard deviation. What is the formula to find the standard deviation if we have frequency distribution table? The standard deviation sigma equal square root sum f times x minus mu square divided by n, or we can replace n with a sum of f, it's the same. So to find the standard deviation, we need to have x minus mu. So we need to add a column here called x minus mu. And then square this value, because we want x minus mu square. So let's square this value, x minus mu square. Then multiply x minus mu square times the opposite frequency. So here we will multiply f times x minus mu square. Now let's fill in this table. Okay, x 4 minus 8 equal minus 4. 5 minus 8 equal minus 3. 6 minus 8 equal minus 2. 7 minus 8 equals minus 1. 8 minus 8 equals 0. 9 minus 8 equals 1. 10 minus 8 equals 2. 11 minus 8 equals 3. 12 minus 8 equals 4. Next step. We need to square this value. Let's square it. 4 squared equals 16. Negative 3 squared equals 9. 4, 1, 0, 1, 4, 9, 16. Last step, we need to multiply each frequency times the opposite x minus mu squared. So 3 times 16, it's equal 48. 10 times 9 equals 90. 18 times 4 equals 72. 20 times 1 equals 20. 24 times 0 equals 0. 20 times 1 equals 20. 14 times 4 equals 56. 9 times 10 equals 90. 16 times 5 equals 80. Now, let's add all of these values together. 48 plus 90 plus 72 plus 20 plus 20 plus 56 plus 90 plus 80 equal 476. So, to find the standard deviation sigma equal square root of 476 divided by 124, it's equal square root of 3.84. Keep it as it is and square root 4. Last measure, which is the variance number 5, as we know, variance equals sigma square. So we will square this value. The square will cancel the square root. So variance equals 3.84.